Hello everyone, welcome to this show. We're going to be talking about not specifically the flat earth, but rather addressing and debunking some of the issues raised on the topic of the flat earth. Now, let's put a little bit of background music on. There we go. So one of the biggest things that's hit the internet in the weird and wonderful sections, let's say, is the flat earth in the recent years. And even if you haven't seen any of the flat earth videos or read any of the flat earth articles, you may have heard about it in the mainstream media. And the first reaction might be, as it was with me, this is absolutely crazy. This is stupid. I cannot believe people actually think this. We've known since we were little kid at school that the Earth's round. We see boats disappear in the distance, going round in the sea. Astronauts fly out in space, and there's pictures from satellites. And besides, it was all figured out 500 years ago. Blah, blah, blah. So we know the Earth's round. And for the majority of us, that's because we were told it was round. So if you think of it another way, if you were beamed down to the Earth today and you knew absolutely nothing, the only thing that you knew was how to speak. You had no knowledge of anything at all. You would think, am I stood on a spinning globe, or am I stood on a still surface? And I don't think anybody can feel the world spinning round. I've never heard anybody say that they can feel it spinning. I certainly cannot. You feel like you're physically as still as a rock. But yet, we know we're on a globe spinning. And the Flat Earth community has presented a long list, actually. In fact, somebody's made a video with 100 reasons why it's a flat Earth. And I think it was called something like 100 proofs that the Earth is flat. Now, we're not going to go through them. Do not worry. And you can look up that. And I'd suggest anybody who has never heard of this or has never looked into it to look it up, and here's why. The flat earth, let's just call it a topic, is a very, very good intellectual test, and that sounds kind of ponzified, but it's a very, very good way of testing your critical thinking, because you can say, oh, the flat earth's stupid, it's silly, it's crazy, it's daft, it's retarded, it's a Psy-op, it's another way the intelligence agencies are splitting up the truth community. It was figured out 500 years ago. God, didn't you go to school? Did you miss out on that? You know. But none of these almost insults, aren't they, actually address any of the underlying issues that are raised by the flat earth community. So, for example, one of the issues, and this is one of the issues that get me, and the reason that they get me is because years ago I learnt how to fly in cadets, the air cadets, and one of the main instruments that you have in the plane is the artificial horizon, and it's like a little ball, it's like a miniature Earth, if you like, where half of it is the sky and half of it is the ground. It's just a little picture in the instrument, and that is called the artificial horizon, which is attached to a gyroscope. Now, before the engine's even switched on, the aircraft's on the ground, you get into the cockpit, and before you start the engine, you're obviously starting the electrics up, one of which would be the radio and the lights, and one of them is the gyroscope that is powered up. And you power up the gyroscope so it starts spinning round. I hope we all know, what a gyroscope is or what it looks like. It's a similar thing that if you might have as a kid, like a spinny top, and you spin it round, and then it spins even though it's only balanced on a point. Well, in an aircraft, you have like a physical metal disc that's suspended in fluid, and it's powered by a motor, and that sets it spinning. And once it's spinning and the artificial horizon is fully leveled out, because you're on the ground, you're level, you cage the artificial horizon, and now what happens is the artificial horizon is now independent of the forces of the aircraft, or the gravity, let's call it, and the artificial horizon is now locked in terms of the XYZ axis and the orientation. So if you're in a plane and you do a loop-the-loop now, if you're upside down and you're doing a loop, you don't feel like you're falling out, you are pushed into your seat with the G-force. And forgive me for going into inordinate amount of detail in explaining this, but it's important because we need everybody to understand this so we can move on. So you're doing a loop and you're halfway through the loop, so the plane is upside down, you are inverted. So if the gravity was to pull you down, you'd be hanging by your straps, only you're not, you're pushed into your seat. That's the G-force that's doing that. It's because you're travelling at a high speed and you're pulling backwards, and the change of direction is causing a G-force. Much like if you're going fast in your car and you turn left or right, you've got a force that's pushing you to the left or the right. That's not because the gravity has suddenly changed direction. It's the G-force. So when the plane's upside down, the G-force is pulling you into your seat. If the artificial horizon, if it was responding to gravity, would show that you're the right way up. Because the G-force is pulling you down. But yet the artificial horizon shows that you are upside down. And the reason it knows you are upside down, there's no computer work that's gone in there. All that it is this gyroscope is now completely disrespondent to gravity, because you caged the artificial horizon before you even left the ground, and the gyroscope is deadlocked into the XYZ axis because it's spinning. That's all it is. The high speed rotation of this metal disc, the gyroscope, in the fluid is going to spin the same direction no matter which way the plane is pointing or which way the G-force is pulling. Now, I'm hoping, to many people, I'm really hoping, that might seem obvious. Yes, a gyroscope spinning isn't going to change direction if it's free floating, no matter what forces or direction the object that is encased around the gyroscope is doing. It shouldn't matter, and it doesn't matter. And that can be proven if you look at any aerobatic video. The artificial horizon is always the same way. Relative to the Earth, always the same way. It doesn't matter if you're doing a stall, if you're doing like the vomit comet, they call it, that plane where they do a 0G. They fly very, very fast and then slowly pitch the nose forward so that there's 0G, and that's where they simulate the weightlessness in the back. But the artificial horizon isn't going berserk, it knows exactly. So, bearing all that in mind, if you were to fly quarter of the way round the Earth, so let's say I'm in the UK, so let's say I was to fly from here to the UK to somewhere like Chicago or even Los Angeles a bit further. I don't know exactly because I can't measure it, but I would suspect that's about 25% of the way round the Earth, and that would explain why it's 6, 7, 8 hours behind us on the time zone. If you were to fly halfway around the world to Australia, that's 50% round the Earth. In a round Earth model, we're all taught that the people in Australia would be walking upside down relative to us. So if you were a quarter of the way around the Earth, somewhere like Los Angeles, relative to the UK, they would be walking at a 90-degree angle to us, with the centre of the Earth being some way below our feet, in between us. So that's what we're taught on the round Earth. So if the gyroscope is spinning, and once it's up and spinning and in the fluid, gravity or G-forces or the direction of the aircraft have no bearing on this gyroscope. It just keeps pointing X, Y, Z the same way until it's powered down at the end of the flight. If you were to take off and fly around for 5 minutes or 5 days and then land on the same spot, the artificial horizon would still point the same way. But if you were to fly quarter of the way around the Earth or halfway around the Earth, gradually the artificial horizon would begin to show that your aircraft is banking either left, right, or pitching forward or back. Why? Well, because if you hold your hand up to the, if you hold your hand up in front of you, actually hold your hand up now in front of you, as though you're waving high, and place that on an imaginary circle in front of you, and that would be the Earth. If you were to fly and move your hand to the left, round the top and to the left of this circle down the left-hand side, you're now 25% round the Earth. But yet your hand is still the same orientation. That would be the same as the gyroscope. It still points the same way. Remember, it's spinning and it's free-floating in the fluid. The forces, the gravity, the G-forces, whatever, have no bearing on which way this gyroscope is pointing. So if you've flown halfway around the world, quarter of the way, doesn't matter, the gyroscope would now be 90 degrees off if you flew 25% round the world. Because if it's a circle, a ball, the Earth being a sphere, if you flew 25% round, you've gone round a 90-degree curve, yeah? So whether that's a bank or a climb or a dive doesn't really matter. What matters is you've gone round a 90-degree curve, irrespective of which way that would be. How then is the gyroscope not now 90 degrees out of whack? Because it should be, because if you've gone 90 degrees round a curve, the gyroscope should now be 90 degrees off centre, off kilter, and that should be reflected on the artificial horizon. Yet it isn't. So some people might say, well, yes, that's obvious, that clearly does happen, and the way the aircraft get around that is there's some computer modelling chip that tracks where the aircraft is and makes a correction for the artificial horizon. And that would be a perfectly reasonable assumption to make, but bear in mind GPS only became public in the last 10-15 years, and it was only invented by the US military in the 90s for the Gulf War. And yet planes were flying in the 80s and 70s, quarter way, halfway around the world without any issue. They weren't falling out the sky. So then somebody might say, well, the computer chips, although they didn't know exactly where the plane was, would make some sort of calculation based on how long they'd been in the air, or the pilot would program in where the plane was going to, and so the computer would have a vague idea where it is and make a correction that way. Well, if you're thinking that, then you're making assumptions based on something where you've got no idea, and what you're doing there is trying to explain away a fact. And this is one of the issue, not just flat earth, but on anything, where you are presented with, or not you, but the royal you, are presented with a fact that doesn't fit with your belief, and in order to explain that fact away, you have to make an assumption, and this is where we get into the cognitive dissonance and confirmation bias. A good example there is the religion, where you pray for something to happen. And if that event then happens, well, God answered your prayer. And if that something didn't happen, well, it wasn't in God's greater plan, but he still listened to your prayer and decided not to do it, and he works in mysterious ways. So, whether your prayer worked or not, there's always an excuse. Well, in this case, back to the flat earth, there is no computer that works out where the plane is and adjusts the artificial horizon and or gyroscope accordingly. And you can prove that two ways. One, you can actually look how these things are made and see that there's no adjustments made depending on the position of where it is, via global positioning system or any other method. And two, just in case you didn't believe the manufacturer or you can't be bothered to do that, you need only look back at when computers the size of a house could do barely anything and realise that was in the 60s, and that planes, jet engines, were flying from the late 40s onwards. They were certainly flying transatlantic with passengers by the 50s, and there was no house-sized computer in those jet aircraft ensuring that the artificial horizon pointed the right way. So you can use common sense and logic, or you can spend the time and research every single individual fact, go online, look at the specifications of the individual items, the individual aircraft, what they're made, and go down to the parts and how they work. Or you can use common sense on things where logic dictates. And so that is one example that has had me stumped. That one example, that one issue of how this gyroscope doesn't respond to that stupid, oh, we all know they figured it out. It doesn't care about what it's called or insults. It's just a fact. It's a simple fact that is difficult to explain away using other facts. Because as I thought, well, computers must do something. And then when I looked, no, there are no computers between the gyroscope and the artificial horizon. And even if there was some tiny thing that wasn't on the diagram, it couldn't have been there 50, 60 or 70 years ago. It just couldn't have been. But I did look at the schematics of the diagrams, and there is no compute. It's all mechanical. It's all mechanical. Then you've got another issue, and you don't have to get in a plane for this. Again with the gyroscope, but bear with me. You get a gyroscope, and you set it spinning, and if you've got some way, like a motorised one, again, I don't know where you'd get such a thing, short of buying one out of an old plane, but if you had a gyroscope and you set it spinning and put it on your desk at home and leave it there, if you believe that you're on a globe and therefore that it spins round once every 24 hours, it stands to reason that this gyroscope would, with every passing hour, gradually move to one side or the other depending which way the Earth is spinning, depending whether you're on the north or southern hemisphere. You'd gradually see this gyroscope changing its orientation further on throughout the day. And in 12 hours' time, the gyroscope should be inverted, and in another 12 hours, after the full 24 hours has passed, the gyroscope should be right way up again, Because if the Earth's spinning round once a day, the gyroscope should spin round once a day once it's powered up. Does it happen? Well, the people who have made videos on this, who've got the most precise gyroscope that somebody with a reasonable budget can buy, can have it spinning for 2 or 3 hours and there is no movement in that 2 or 3 hours. Well, we already know that 12 hours, it would have to be halfway round, as the Earth spins round halfway in 12 hours. So if in 2 or 3 hours there's no movement at all, whereas we should expect to see, at least 30, 40, 50 degrees of motion. I mean, if 12 hours is 180 degrees, then 3 or 4 hours clearly should be somewhere between 45 and 60 degrees. So that's something. Then there's the issue of ships disappearing, over the horizon. I happen to live on the coast in the UK, and I can attest to the fact that ships do disappear over the horizon as they sail off into the distance. And then there were videos made where people zoomed in with telescopes or whatnot, and it brought the ship back into view. Well, I had to test this out, and I have a zoom lens on my Nikon camera, and so I went down and I zoomed in all the way, and yes, the ship that appears to have disappeared over the horizon, you can then see again and make it out. And not only that, you can see the lower part of the boat, but then there's like this mirror line. It's hard to explain, but you don't see the waves on the bottom of the boat crashing. You see there's like a mirror, like a mirage almost, and whether it is a mirage or refraction, I don't really know. I didn't look into it that much because I heard a lot of, well, it's refraction, it's a mirage, it's a reflection, it's the moisture in the air, it's this, it's that. What you get is a lot of different opinions, and then you get this, well, it depends how hot it is and how much moisture, and the fact is, you cannot accurately measure how much heat and moisture is in the air and how much curvature there is and make any real scientific measurement there. And so it is something to take on board, but at the same time, you've got 2 different people with 2 different opinions, or 5 different people with 5 different opinions, and there's no precise way of measuring who's right and who's wrong, even if we were all to agree on the basic facts, because the equipment simply doesn't exist to do that. So it's best to stick to something else, such as, does light bend? If you were to shine a laser beam over a mile, does it dip down? And most people would argue, no, there is not enough gravity on the Earth to bend the light in any meaningful way over large distances. And I live on not exactly a bay, but the land does curve round a bit, and there's a town about 10 or 11 miles away from where I live, down south along the coast, and it's along a curve, slightly, the coast curves slightly so I can see the town at night. And I've put my camera as low down to the beach as I can, where the sea is, and photographed across at night, and I can clearly see all the street level lights in that town, which is 10, 11 miles away. And when you actually ask Google, so this isn't asking a flat earther, you ask Google, how far away is that town, and then how much curvature should there be between here and that town, putting that distance in, and you'll find that the amount that the curvature should be, let's say that should be 30, 40 feet behind a curve. So you think, well, I know that those street lamps are 15 feet high. So deduct 15 feet from the 30 or 40, deduct the foot above the ground that I'm holding my camera at this end, well, they should be 14, 15 feet behind the curve. Yeah, I can still see it. So all these are little dots that sort of persuaded me that there was something to this flat earth business. And there's loads more. And so, but just because you've proven one thing or disproven one thing doesn't immediately mean that, aha, I've got it. For example, some people say, well, what about the pictures from space? That clearly shows it's round. Therefore, aha, that's it, done. And then on the flip side, you'll get, well, I've proven that this photo or this photo from NASA or whoever was faked, and therefore the whole thing's fake. Aha, got you. Which again isn't true. I could fake a photograph of where I live. Does that mean where I live doesn't exist? No, of course it doesn't. It just means I faked this photograph. So if NASA is faking photographs from space, and we know they have done, does that mean they've faked every single photograph from space? No, it doesn't. It does raise an eyebrows and a question as to why they are faking photographs in space. But it doesn't mean every photograph is faked. Unless, of course, you can prove that every photograph is faked. One of the big giveaways was, not so much recently, but especially in the older days, when they used to have a lot more video from space and they did spacewalks and so on, every so often you'd see little bubbles coming out of the astronauts' helmets or their spacesuit. And this was challenged once to one of the astronauts. They challenged why, it was asked in a press conference, why sometimes do we see bubbles coming out of your spacesuit? And the astronaut, like they do, they cleverly avoid answering the question by pretending they misunderstood it. And they said, well, sometimes when we drink in our spacesuits, there might be a little bubble that comes that way. But you see, the guy was on about the bubbles coming on the outside of the spacesuit, not on the inside. But of course, by the time the guy's responding to him in the press conference and he's got the microphone, the other guy can't say, no, what I meant was the outside, because he's obviously drowned out. So there are occasionally bubbles, and again, you can look this up, on the outside of the astronauts. And you can tell this isn't faked video footage, because if I downloaded a video from NASA and faked it to make it look like there was a bubble, you could then say, well, I see this bubble on your video, but here's the original on the NASA website, and there's no bubble there. Yet, if the bubble is on the video from the NASA website, it's a lot more difficult to say that somebody faked that. Of course, there could be somebody from NASA adding fake bubbles onto the spacewalks in real time. I don't know why they would do that, though. Again, just because there's fake video and photos from space, from NASA, officially, doesn't mean that they haven't been there. It just means those photos and videos are faked, and so it doesn't prove anything one way or the other. So you have to, negate that. I mean, if you've ever been caught for speeding, does that mean you speed all the time? And somebody else who's never been caught for speeding, does that mean that they've never ever once speeded? No. It just proves that it has happened or it hasn't, but it isn't a permanent 100% constant thing. This is the critical thinking that unfortunately is lacking with so many people. And both sides of this flat earth, round earth conspiracy, if you want to call it that, are guilty of this. There's this lack of understanding the information the person is putting forward. And I'm doing a terrible job at it, I know, but I'm trying. And to properly debunk, which is what this video was about, to properly debunk the flat earth, you need to take the piece of information, the fact that's put forward, understand it yourself, understand what the person is saying, without calling them, you're just stupid, you're a shill, it's a side. Because none of that debunks what is being said. And if what is being said, let's say, I know that the earth is flat because the sun moves round in the sky and the earth stays still. Right? So that's what I'm saying. Well, that can easily be challenged, because the response to that could be, well, how do you know that the earth isn't the thing that's moving and the sun is staying still? And from the information that I just gave, you don't. I would have to add more information. And that's how it works. And when you put one fact together, and another fact, and another fact, and another fact, and so on, you can then start to draw a conclusion. What you cannot do, and this is anybody, it doesn't matter which side you're on, is, oh, here's a fact that supports my theory, and here's one that I think supports my theory, and here's another one. Yeah, that kind of got me, that one. I know, I'm going to throw it away, I'm going to ignore it, because I'm just trying to back up what I think my theory is, and I don't want to hear anything that brings that into question. Because that isn't being honest, first and foremost, with yourself. And the number of times you sometimes see it on a video, somebody's talking, and they'll say, oh, I think this, and then they'll maybe go to a website and try and prove what they're saying, and then you see that the website proved them wrong, and you see them realise as they're trying to, and they don't say, oh no, actually it doesn't, does it? They keep going. And because the information in front of them is proving them wrong, they start trying to talk over, like, oh, well, yeah, and they probably got this thing wrong here, and that, because the person has realised as they're talking, shit, I'm wrong. But they're still going on, and they're still going on, because they have this pride ego thing. Cannot be proven wrong. You cannot prove me wrong. Nobody can prove me wrong. And if they can, I'm still not going to admit I'm wrong. I'm going to say they're wrong. And if they have me banged to rights, I'm just going to say, you're really an arsehole, aren't you? It's your fault. You're really idiot, aren't you? Were you always like this? I bet you don't have many friends, do you? Yeah. Rather than saying, yeah, I see what you're saying. That's a good point, that. Do you know, I hadn't thought of that. I hadn't put it like that before. I see what you're saying. That's it. And this is the problem that we have. And if we're going to try and debunk the flat earth, we need to stop with the name calling. And the flat earth people need to stop calling other people brainwashed globe-tards or whatever. And we need to stop calling them crazy flat tards, because neither is solving it. I see what they're saying. They think we're like sheeple because we were told at a very young age with a globe in the classroom the earth is round. Yes, we were. We were told at a young age, so we didn't have the skills able to critically think and question what we were being told. Yes, that is true. We didn't have the skills. I would argue many people today don't have the skills to question what we were told. Whether now or as a young kid, we don't have the skills. Many of us. And I believe that was deliberate. That isn't a fault of the people. That was a deliberate plan. Because the education system moved away from teaching skills and how to think critically and problem solving, and they moved into how do people feel about this, and the political left-wing agendas about that are good, and which sex do you think you belong to? Here's 35 to pick from. That isn't education. That's wasting children's time to become retarded. It's all about thoughts and feelings, and I think this about how you feel and how I felt about you saying this word, and all the facts have gone out the window and the critical thinking's gone out the window. It's just how, and I feel this way about that fact, and therefore I don't like it, and that fact, despite it being true, I feel hurt by it, and therefore the fact is wrong, and you're wrong, and if you don't watch it, your free speech is going to get banned, because I know your fact is right, but the feeling hurt. And alright, I got a bit off track there, sorry, but this is the problem. So to debunk, here's what I think. I don't think it's flat, the earth, and I don't think it's round. And so you're going to think, what on earth is he talking about now? Is it hollow? Is it convex? No, I don't think either. So here is what I would say. Many, even mainstream now, scientists, especially in the quantum field, have started to come out with this theory, and it's been widely accepted. I think over 90% of scientists are on board with this now. Then again, I read that fact in the mainstream media, so don't quote me on it. That we live in some sort of simulated universe, some sort of matrix, if you like, a holographic universe. Well, if it's a holographic universe and a simulated one, and they're basing this off, well, computer games we know are starting to get better and better graphics. It used to just be Pong, a couple of lines and a ball. Now you're getting more and more advanced and you've got virtual reality headsets. And they're saying, if that was to continue to advance at the current pace, how long would it be before the game world was indistinguishable from the real world? If we were to cortex, neural lace the computer game into our brains, not that I'm suggesting we should, but if we were, so that every sense was stimulated, taste, touch, sound, sight, smell, and we thought we were moving round and the graphics are amazing, we can hear things, and we're all there in this fully quad HD VR amazing reality computer simulation, we wouldn't know the difference between being in the game and being in reality if the graphics were that good, the sound and everything else. And so the scientists have all come to the conclusion that if that was the case, therefore the chances are 1 in a billion that we are not already in a simulation by whom wasn't addressed, but already in one, like a matrix. And that is why certain things that we call paranormal or magic actually are perfectly normal, because it's in the game. Einstein said nothing could travel faster than the speed of light, no matter, no object. And yet we now know through quantum physics and quantum mechanics that we have this thing called quantum entanglement, where a particle, no matter the distance, whether they're light years apart or just in the next room, respond instantly to one another when they become entangled. And so as one rotates this way, the other one rotates that way. It doesn't matter the distance, and the effect is instantaneous. So clearly something somewhere there is travelling faster than the speed of light. And the only way that that's possible, while holding on to Einstein's no physical matter can travel faster than the speed of light, is if the information, if you want to call it that, the properties of particle 1 that's here and particle 2 that's way, way over there, is if the information on particle 1, the properties, is kept outside of the reality, and the same for particle 2, and the same for everything else that exists. And because these two particles are quantumly entangled, if particle 1 starts to move this way, in the properties it would say it moving this way, and then that property is already linked with the property of the other particle, zillions of light years away, but the properties are right next to each other, like on another layer, on another dimension, if you like. And that's another thing. The double slit experiment. We, as humans, as sentient beings, are able to affect the outcome of an experiment just by looking at it. And if we don't look at it, the results are always different. So the results are always a wave if we don't look at it. And then if we repeat the experiment, only needs one of us to look at it. We're trying to identify which slit this particle goes through. to make this wave, we find there is no wave. There is now a pattern. So we look, there's a pattern. We don't look, there's a wave every single time. What changed? The only thing that changed is somebody, a sentient being, was looking to see which gap, which slit of the two slits, the double slit, the particle went through. That right there, with the other bits of information, the physicists, this is way beyond my pay grade, have discovered that in the very fabric and makeup of the universe, the makeup of the fabric of the universe, the physical electrons and protons and everything else was code. He says very similar to the code that runs in your computer browser, your internet browser, to fix errors. He says we found a very similar code in the very fabric of the universe to correct and fix little errors in the universe. Well, how's that possible? Well, the answer, it's a simulation. It's a grand glorified computer game. Well, if it's a grand glorified computer game, to tie this back round, a huge simulation, a massive holographic reality, is the Earth flat or round? The answer is it's neither, and it's both at the same time. It could be round if you could get up high enough away from the Earth, it could be round. And then when you get down onto the Earth, it could be flat as a pancake for 1,000, 5,000, 10,000, 20,000 miles, and you could keep going in a straight line. Would you end up back where you started? Well, the answer could be yes. Because if you're in a computer game and you go off one side of the screen, have you ever reappeared back on the other side of the screen? Well, yeah. There has been such a game, I'm sure. Okay, so if you go off one side of the screen and go back onto the other side of the screen in your computer game, is the monitor round? Is it a ball shape? No. Well, how did you get back on the other side of the screen then? The answer is because you didn't actually move round to the other side of the screen. The computer game, the simulation, the holographic reality placed you on the other side of the screen when you fell off the other side. And in that respect, I believe the world isn't round. It's not flat. It's holographic reality. I agree with the physicists because I understand what they're saying. I understand the principles that they're laying out, and I can't see a flaw in any of them. But I will end with this. Does that mean it doesn't matter what we do to this Earth if it's just a holographic reality, if it's just a simulation, just a game? Can we pollute it to bits? Can we irradiate the seas? Can we eat and drink junk food so we get, drunk and fat and unhealthy and diseased? And no. And here's why I say no. Because no matter how much of a game it is, we've all got to play the same level. We're all in this game together. We're all in the same level of this game. And if I ruin my part of the game by making lots of rubbish and smell and pollution and poison and I better skip loads of it and I'll start tipping it all over the roads. The other people in the game, the simulation, the reality that we are in, have all got to live that. And so I think it does matter. Why are we here? Who knows? Some argue it might be like a school. Some say it might be like a prison. Others just say it is what it is. And some others still say, we don't know, we're still trying to figure it out. Anyway, please enjoy the rest of your day. It's been a longer one than I thought, but the answer to debunking the flat earth is to listen to the points made and address them, not avoid the points and attack the individual, the person, because that's the easiest thing to do. It solves nothing. It deepens the divide because both sides are just going to continuously divide if you do that. We need to come together, listen to the other side, and honestly and fairly debate the facts. Take care. Bye bye.